the midpoint of the Second World War. The skies over Europe were the ultimate proving ground, a relentless three-dimensional battleground where speed and altitude meant life or death. The sound of that war was the whine of a supercharger, the rattle of machine guns, and the deep, throbbing pulse of 1,000 engines. In the midst of this aerial contest, one aircraft stood out, not for its sleek, deadly grace, but for its sheer, uncompromising bulk. This was the Republic P-47 Thunderbolt. To its American pilots, it was affectionately known as the Jug, a juggernaut, a brute of an aircraft, heavy, massive, and seemingly impervious to damage. When the P-47 first appeared over the continent, the pilots of the German Luftwaffe looked down at the new American fighter. They saw a fat, clumsy giant compared to their own graceful Messerschmitts and Focke-Wulfs. They laughed, but that laughter was about to give way to a cold, engineering dread. The primary mission of the U.S. 8th Air Force was to bomb Germany into submission. But without protection, the heavy B-17 bombers were simply targets, falling by the dozens. The American strategy demanded a fighter capable of something truly radical: deep penetration. An escort that could fly hundreds of miles, climb to the bomber's high cruising altitude of over 25,000 feet, and still have the power to fight off waves of determined German interceptors. The P-47 was the answer. It wasn't designed to be light or elegant. It was designed around an ethos of endurance and survivability. It had 8.50 caliber machine guns in its wings, a massive fuel capacity, and an airframe built like a flying brick outhouse. But all of this, all of the weight and the firepower, depended on one monumental component: its engine. The heart of the Thunderbolt was not merely an engine. It was a feat of American industrial supremacy. The Pratt Whitney R-2800 double wasp, a huge, air-cooled radial engine, bristling with 18 cylinders arranged in 2 rows. At a time when a successful fighter engine might produce 1,200 or 1,500 horsepower, the R-2800 was delivering an eye-watering, guaranteed 2,000 horsepower, a figure that seemed to belong to a motorboat, not a compact fighter plane. This massive output was necessary just to get the P-47's 14,000 pounds of combat-ready steel and fuel into the sky. This was the American approach. When in doubt, add more power. This was a direct, raw assertion of brute force engineering, and it stood in stark contrast to the refined, lightweight designs favored by the Germans. The Luftwaffe pilots knew the P-47 was a tough customer, but they still couldn't fathom how such a heavy aircraft could possibly match their speed and climb rate at altitude. For months, the Luftwaffe was forced to fight the P-47 in the air. But as the war continued, the inevitable happened. Somewhere over the Reich, perhaps due to a navigation error, battle damage, or simply a lack of fuel, a P-47 was forced to make a controlled landing on German-held territory. The crash landing, though damaging, left the core of the aircraft, the massive nose section and its engine, remarkably intact. German ground forces secured the prize quickly. The wreck was an immediate, top-priority intelligence asset. It was carefully dismantled and transported to the Luftwaffe's most secret facility, the Technical Evaluation Center. For the chief engineers of the Daimler-Benz and Junkers companies, the architects of Germany's sleek, liquid-cooled power plants, it was the moment they had been waiting for. They were about to put the American monster on the dissection table. They were finally going to uncover the secret of the P-47's immense strength. The German engineers expected a look at a crude, overweight machine. What they were about to witness was not crude, but an engineering masterpiece, a shock of industrial complexity that would expose the fatal flaw in their own air superiority strategy. The first great surprise was simply about to be unveiled. The Germans approached the captured engine with a distinct bias. Their engineering philosophy revolved around the liquid-cooled, narrow V12 inline engine. The Daimler-Benz 601 and 605 series were masterpieces of efficiency and low drag. The Germans believed the American choice of a big, bulky, air-cooled radial engine was a technical compromise, crude, inefficient, and slow. The radial engine was considered an anachronism, a legacy of a bygone era. German engineers prioritized the sleek aerodynamics of the inline engine, which allowed their Messerschmitts to achieve higher speeds. They believed the P-47's huge nose was a consequence of American technical inferiority. But the moment they began to take the Pratt Whitney R-2800 apart, their assumptions began to crumble. This was not the relic they expected. This was something entirely new. The first physical shock was the sheer scale and complexity of the 18-cylinder two-row radial. It was a tight, compact powerhouse, built with a level of industrial precision the Germans struggled to match under wartime conditions. The engineers marveled at the metallurgy. The Americans were not only using superior-grade aluminum alloys, but they were manufacturing forged aluminum pistons with an incredibly complex internal geometry. These pistons, subject to the tremendous heat and pressure of 2,000 horsepower, were designed for durability, not lightweight performance. The precision of the roller and ball bearings that allowed the complex crankshaft to handle the engine's enormous torque was equally astonishing. This wasn't just more power, it was power manufactured to last. The German engines were often on the ragged edge of failure, easily damaged by a single bullet. The R-2800 was engineered to absorb damage and keep its plane in the sky. The realization began to dawn. The American focus wasn't just how fast the plane could go, but how long it could endure. The 2,000 horsepower figure was impressive, but the real secret to the P-47's dominance, the engineering detail that stunned the German analysts into silence, was the way that power was maintained at extreme altitude. The problem of high-altitude flight is simple. The air is too thin to properly feed the engine. The solution is the supercharger, which compresses the air before it enters the cylinders. While German engines used mechanically driven superchargers, which worked but sapped the engine's power, the P-47 utilized a massive, General Electric exhaust-driven turbo-supercharger. This turbine was spun by the engine's own exhaust gases, essentially recycling the waste energy to force-feed the engine compressed air. And here was the engineering genius. The enormous turbine wasn't located conventionally next to the engine. Due to the engine's radial design, the turbo was installed in the very rear of the fuselage, near the tail, connected to the engine by a long, serpentine, 20-foot ducting system. The German engineers were aghast. The sheer complexity and necessary reliability of the long ducting, which snaked under the cockpit, was beyond what they thought feasible. They had dismissed the P-47 as a heavy brute. Now they saw it was a sophisticated, pressurized system of pipes, cylinders, and turbines, all perfectly balanced. The shock was multifaceted. First, they saw that the American engine was not losing power at altitude. At 30,000 feet, where the German fighter's performance began to drop off sharply, the P-47's R-2800 was still pouring out its full 2,000-plus horsepower. The fat, slow jug was suddenly capable of out-climbing and out-diving their best planes where it mattered most, in the bomber's airspace. Second, the German engineers had themselves explored radial engines and turbocharging, but they had always discarded the concept due to the enormous manufacturing demands and the scarcity of high-grade alloys. The captured engine proved the Americans had overcome these hurdles through industrial capacity that dwarfed their own. Third, and most important, they realized the engine's size and structure made it incredibly robust. It was protected by its own cooling fins and a heavy shroud of metal. The Germans' delicate, liquid-cooled engines were vulnerable to a single shot to the coolant lines. The R-2800 could take multiple hits and keep running. The laughter was completely gone. In its place was a chilling respect. They had opened the chest of the jug and found a heart of steel, powerful, complex, and brutally unyielding. The German high command now knew they faced not just pilots, but an unstoppable tidal wave of superior engineering. The detailed technical report filed by the German engineers was grim reading for the Luftwaffe High Command. The conclusion was undeniable. The sheer power and reliability of the Pratt Whitney R-2800, coupled with its advanced turbo-supercharger system, was a technical benchmark Germany could not hope to match in the short term. The engineers lamented the lack of critical resources. Germany lacked the volume of high-quality aluminum and specialized alloys needed for the double Wasp's precision components. They also lacked the massive industrial capacity, the assembly lines, the machine tools, to produce such a complex, large-scale engine reliably and quickly. The engine was more than just a piece of machinery. It was a physical embodiment of the American industrial philosophy. Focus on overwhelming power and battlefield reliability, even if it meant a compromise on traditional aerodynamic elegance. The German engineers had to acknowledge that in the brutal arithmetic of air warfare, brute power had trumped sleekness. The presence of the P-47 Thunderbolt, powered by the double Wasp, fundamentally changed the balance of the air war. Before its arrival, German interceptors could simply wait above 25,000 feet, where the high-altitude performance of their own fighters gave them a decisive advantage over the bombers. With the Thunderbolt in the sky, that sanctuary was gone. The P-47 could climb with the best of the Luftwaffe, and with its immense weight, it could execute high-speed dives that no German plane could safely follow. It performed the vital initial function, protecting the B-17s during the deepest penetration raids, allowing the bomber formations to survive and drop their payloads. The P-47's 2,000 horsepower engine ensured that the American bomber offensive could continue unabated, day after day, week after week. It was the heavy fist that kept the skies clear. Post D-Day, the Thunderbolt found its true, legendary calling, the mud mover. The engine's high performance at altitude was now complemented by its unholy power at low level, transforming the Jug into the ultimate ground support aircraft. The R-2800's air-cooled radial design proved its greatest asset in this dangerous role. Unlike the fragile coolant lines of German engines, the radial's cooling system was extremely robust. The engine could literally absorb countless rounds of small arms fire from the ground, losing a cylinder or two, and keep on running. Carrying a massive payload of bombs, rockets, and the stinging fire of its 8.50 caliber guns, the P-47 became the bane of German ground troops. It was the ultimate tank buster and artillery spotter, a flying testament to the principle of rugged, unyielding design. The legend of the Thunderbolt's indestructibility was not a myth. It was the direct result of the 2,000 horsepower R-2800 Double Wasp's brutal, damage-tolerant engineering. The Pratt Whitney R-2800 Double Wasp went on to power numerous iconic aircraft and remained in service for decades after the war. It was far more than an engine. It was a symbol of the war's turning point, a victory of industrial scale and pragmatic, power-focused engineering. The story of the captured P-47's engine is a moment of pure, sobering reality for the German war machine. The engineers who first mocked the fat American fighter found that its weight was its strength, its bulk was its protection, and its power was its secret. They had scoffed at the sight of the huge radial, but when they finally saw the complex core, the 2,000 horsepower beast and its ingenious turbo system, they understood. They were not fighting an airplane. They were fighting an industrial titan. The laughter was silenced by the realization that they could not match this level of engineering excellence. The Double Wasp didn't just power an airplane, it powered a continent to victory.